Zachary Jackson, and I'm majoring in aerospace engineering.
I'm Andrew Gallegos, and I'm also majoring in aerospace engineering.
I'm Dominic Costantino, majoring in aerospace engineering.
I'm John Perkins, I'm majoring in aerospace and mechanical engineering.
And this is our project, Gary 2.0.
We are developing an automated construction car that will be able to follow the lines of the road and fill cracks as it senses necessary. So we have, of course, the 2 motors on the back that allow it to turn, the 4 separated axles, 4 wheels, and then sonar on the front. That way it can stop in front of an oncoming obstacle. And then, of course, the sensors and circuits inside to operate the code.
So I'm going to explain to you a little bit about what our circuit does in order to operate our car. So in the front here, we have a sensor that is designed to stop the car if it ever gets too close to something. And the way that's set is we have this blue wire right here attached to the 12 and the black one and connected to the 13, which is the trig and the echo pin in order to measure how far away it is. And then the Arduino is powered by this 9-volt battery right here. And then the Arduino is also connected to this this breadboard right here. So right here, this part of the Arduino, the 2 through 7 is connected to the switch right here, which powers this switch and when it turns on and off, which is then connected to each separate motor. And the way we have these motors turn on is through this IR receiver. So if I was to hit this on right here, as you can see, this is poorly connected, but this motor starts spinning right here. And then this whole breadboard itself is powered by this little pack of batteries, which is 6 volts. And then we also have our photoresistors right here. And the way that they're powered is they're connected to the breadboard, which is then in turn connected to the Arduino, which is through the analog because it has to read through analog read. It will tell us what type of light is coming in. Then we can code it to say if it's greater than or less than a certain type of light, then it will stay on the track that we set in the middle of the car.
So our code for this project, we start off just by importing the libraries for servos and for our IR receiver so that we can use the code for those inside. Then this just declares the pin that is used for the receiver. And we have all of our variables that are used throughout the code for our sensors and our servos and stuff. And then we go into the setup where we declare all of our pins. So these pins are for our photoresistors. Then these ones are for our light sensors. This is for our servo. These pins are for our motors. Then this enables our serial and enables the IR receiver so we can use it, and then we go and start all the motors in the off position because that's how they should be when we want our code to run. Then we go into the loop, which is where all of the actual code that runs it is. So we start off by decoding the value of the IR receiver, which is just so that we can remotely control everything and we can print the values of what the code is so we know what case we need to use. So then throughout here we have these switch values which switch what the case value is for everything. Every case value is a different button. So this case negative 23,971 is just the power button case. So anytime we do that, we have a variable for on off. When there's a remainder of 1, then the power button is actually like it runs the code because it shows it's on, and then if it's not and there's no remainder in it, then it just turns off the system. Then we have other case values for like our button 2, which we could use if we just wanted to go forward, and it writes it like that and then breaks out of the code. We have a case for the left button, which turns it left, the right button turns it right, and then backwards just brings it back. And after this we have so we write to the distance sensor, and then we delay it, so we wait for that, and then we write to it, so we see or we start in an off state and then we ride to it and turn it on, and then we turn it off again after waiting. So that just gives it like a brief time period so that we can actually like tell how far away objects are. Then using this, we determine what the distance is using what we got from the input of that. And then if it's less than 3 inches, then it turns off all the motors, so if there's an object in front of it, it won't run into it. Then we go into our photoresistors. So we set these we set the integers to read off the analog pins. So we get it from that, and then this is just for us to be able to monitor what the resistors are actually reading in the logs. Then this is the on-off state that I was talking about with the power button, and then if that's true, then it runs a thing, and so if the left light has a lower value, then it will start to turn right to correct for it, so it's following along the path that it needs to be on. The right light does the same thing, but it turns left instead. And then if we have both of them so that they're over it, so both are sensing that it's on the tape and running, then it just continues to go straight, as well as it opens the servo that the liquid would come out of. But if they aren't both, or if they're both off of the tape, then it knows that it needs to close it, so it's not just pouring out onto the ground when there's no crack detected. And then at the very end, we just turn off everything.